So these notes go along with the foldable that you can get from your teacher if you're not in school. You can just take a piece of paper and make one here in a second, or wait till you get back. A couple things before we start, just some general vocabulary with sequences. Sequences are lists of numbers, and they're either going to be added or multiplied to get the numbers. And so I put some vocab on the foldable. Use of one, that means the first term. And then these two things are called U sub n, or the general term formula. Okay, and so there's a few examples. And whenever it says find the general term, that means find the U sub n formula. So for instance, the terms are always listed by a sub number. So this means n equals 20. So that would be the 20th term in a sequence. And you look down here as an example, I listed a sequence. There's U sub 1, there's U sub 2, etc. So this is your foldable. And so you're going to fold on this right here, and then you would cut up to here. Don't cut it all the way across, or you have 4 pieces. And so then that would be the outside of the foldable, and this would be the inside. So the inside has examples, the outside has the terms, so you can look up and see what you're doing. Okay, so the first kind of sequence is called arithmetic, and it's like the word arithmetic, but we say arithmetic. And so that has a common difference. And so the first thing you want to do is find the common difference. So here the common difference is D is 6 because it's going up by 6. The way you find it is take any term and subtract the term before it. So if you're trying to prove that it's arithmetic, you show that subtraction. So in this case, the first term is 19. So using our formula to write the general term formula, U sub n equals U sub 1 plus n minus 1 times d. So the first term is 19. We leave the n, and the common difference is 6. You can leave it like this. You can also distribute. Sometimes you'll see it distributed. So our nth term would be 6n plus 13. And you can check it. If you plug in n equals 3, that would find the third term. So 18 plus 13 is 31. So that you can check it to see if it works. That is the general term formula. The second example, again, find the common difference. If it's getting smaller, the common difference is negative. So in this case, the common difference is -4. The first term is 101. So U sub n equals U sub 1 plus n minus 1 times d. And then you just plug in your numbers. Again, distribute. So 101 plus -4n plus 4. So any term would be -4n plus 105. And it's always worth testing it. Let's test it with the fourth term. -4 times 4 plus 105 is equal to 89. So that's just finding the general term. Arithmetic sequence means it is going up or down by the same amount. You can list the terms out to find terms, but if we wanted to find like the 100th term, we wouldn't want to list it all out. We would want to use our formula. So if we were finding the 100th term, we just would plug in 100 for n. So for that one, it would be -4 times 100 plus 105. That's way easier than listing everything out. The next kind of sequence we will deal with is called geometric. And this is an exponential sequence. And so like compound interest, remember that compound interest formula we used a little bit, that is geometric. So I'm looking to see what am I multiplying by to get to the next number? Or undoing it, to find it, you'd say any term divided by the previous term should be the same. So in this case, I have r equals 2, u sub 1 equals 3. So my nth term formula says take the first term, which is 3, times r to the n minus 1. Now, you remember from exponents that you can't multiply the 3 and the 2 because they aren't the same base. So that is not 6 to the n minus 1. It's 3 times 2 to the n minus 1. If I want to check it, let's check the third term. 2 to the 3 minus 1. So that would be 3 times 2 squared. 4 times 3 is 12. And that matches my third term. The general term formula is this right here. On the second one, I have some fractions. This is where you might need to know, like, what's happening here. So I'm going to take negative 1/8 divided by 1/16, which is the same as negative 1/8 times 16 over 1. That's negative 2. I could also take the next term, 1/4 divided by negative 1/8, which is the same as 1/4 times negative 8. So you get, as long as you know, you get the same thing. So in this case, r is negative 2. So my nth term formula is the first term times r to the n minus 1. So if it's negative, a couple things to notice. If r is negative, you notice these signs go positive, negative, positive, negative. That's one way to know if it's negative. If you have a geometric sequence that's getting smaller, so we divided by 2, divided by 2, divided by 2. That means your r value is less than 1. So if r is ever less than 1, then your sequence is getting smaller. Okay, so there's two examples of each kind. The next thing we can do is find the sum of these different sequences. And the first thing you got to do is determine what kind of sequence it is. So if you look, this is on the examples for sum of arithmetic sequences. So I know it's arithmetic. Sometimes I don't. But I know the common difference is 2. And I know the first term is 3. And so then I can plug in using either one of these two formulas. The second formula is just the first formula with the formula for u sub n substituted in. So if I want to find the first 100 terms, that means n is 100. So the sum of the first 100 terms is 100 divided by 2. 2 times the first term plus 100 minus 1, because the n is 100, times the common difference, which is 2. And that would give me the sum. Oops. So then it's just a calculator problem. 99 times 2 plus 6 times 50. And again, you would not want to have to list out all of those numbers. You could, that's the long way. So that's the sum of an arithmetic sequence. Okay, this one is asking a little different information. It says the second term is 5. And then we have a third term, and then it says the fourth term is 1. So I don't know the first term. I need that from my formula. And I don't know the common difference, but I can use some common sense. I took something times d, or something minus d, to get to 1. Well, on this one, you can kind of figure it out. If we're a difference of 4 there from 5 to 1, and we did d twice on there, that means d has to be -2, because this is subtracting by 2 and you get 3. This is subtracting by 2, you get 1. That means that this first term was 7. So once I know that, to find the first 20 terms, I can use my formula. I'm going to use the second formula again. And just plugging everything in. So 20 divided by 2, 2 times the first term, plus 20 minus 1 times the common difference. So that's going to be negative 24 times 10, negative 240, which should make sense because if you kept this thing going, these are all negative over here. So if you're probably going to use the second one more. If you ever use the first one, this means you know the first term and the last term. That's the shortcut method. If you know the first and last term, you can add them together, take it times n divided by 2, and you got it. Okay, so to find the sum of a geometric sequence, we first needed to find out what the first term is, so I know it, because that's in both formulas. This is just a rearranged version of it. You could use either one. And I need to find the common ratio. So what is happening? 2 divided by 1/2. Well, that's equal to 4. Four divided by 2. Now that's an error. This should be 1. Sorry. You can fix that on your foldable. So what's happening is that we are multiplying by 2 every time. So R is 2. Hopefully you're listening with the volume on. So U sub 1 is 1. R is 2. To find the sum of the first 7 terms, this is small enough you could list them out, but we're going to practice the formula. So sum of the first 7 terms is the first term times 1, I'm going to use that second one, 1 minus 2 to the 7th over 1 minus 2. So 1 minus 2 to the 7th over negative 1. So do that on your calculator. You get negative 127 divided by negative 1, which is 127. Okay, if you did it in the other formula, it would have just made it positive. It doesn't really matter. Use the first one if R is positive. Generally, that's what we do, but it doesn't really matter. Okay, so this is where you really need the formula because you could have listed those out. You're finding the first 100 terms. Okay, so all we know is that R is negative 1/3. And it looks like my foldable did not have the first term on it. So add that first term. We're going to say the first term is 9. Okay, so if the first term is 9 and R is negative 1/3, I'm going to plug in my formula. I'll use the bottom one again. The 100th term, the first 100 terms is U sub 1, 1 minus negative 1/3 to the 100th divided by 1 minus negative 1/3. So just be careful here. Use your calculator. When you put negative 1/3 in your calculator to the 100th power, make sure you put it in parentheses. You might get some weird stuff going on. When I put that in my calculator, I get 1.94 times 10 to the negative 48, which is essentially 0, divided by 1. This is 1 plus 1/3, so divided by 4/3. So it's really 9 times 3/4, so 27/4. One of the things that is interesting about arithmetic sequences or geometric sequences is that the bigger this goes, the more finite this number is. You'd think it'd be a bunch of decimals, but if you think about what happens here, so if we're at 9 and we divide by -3, or we multiply by -1/3, and we keep doing that, pretty soon, we listed those terms out, pretty soon these numbers are basically becoming nothing. So the only thing you really are adding are just that beginning value. If you look, 27/4, that's 6 1/4. Here's 6. Then all the rest of these together are going to add up to 1/4. So if we would have done this to the thousandth, we would have got the same answer. So the bigger that number gets, the more it changes. So I will add that u sub 1 equals 9 onto the foldable. I'll change this before I send you guys the video. But that's just your basic notes. We'll do more examples in class.